Hello, this is a video on direct variation. What does it mean? A relationship between two variables in which one is a constant multiple of the other. When one variable changes the other in proportion to the first. What we say is y varies directly with x. And the equation that will work for this is that y is equal to k times x. What's the k? The k is a constant. All right. So if someone gives you like a chart and they're asking you to determine whether this chart, this data set, is going to represent a direct variation, you just have to divide and check. You see, to determine whether the data set shows a direct variation, you divide the y by the x and see if you get the common ratio. And so 72 must be divided by 12. And maybe you don't know, maybe you need the long divide, but you could reduce and see that they share common factors. But what ends up happening is that 12 definitely goes into 72 evenly. Without a remainder, what we get out is a 6. Okay? Now we need to check and see if the other ones are like that. And so we move on and we divide 150 by 25. And just think about money. If you have $1.50, how many quarters do you have? It's going to also be 6. But what you can do, see, division is difficult, but multiplication is not as bad. You can just check and see if 25 times 6 is 150. Just long multiply it out. When you get to these other numbers, I don't know how many times 32 goes into 192. I can't use money for that. And so for that, I'm going to check and see if 32 times 6 is 192. It is. Great. I don't know about 44. I don't know multiples of 44. So I'm going to check it out. I'm going to multiply 44 by 6 and see if I get 264. I do. It works out. Every one of these ratios is 6. And so this table represents a direct variation. They don't ask us what the formula is, but what we're finding here, this value, this ratio, it's what k is. Y should be equal to 6 times x. Okay, so that's number 1. Now we look at number 2. Same question, same type of question, different chart with decimals in it. Same process. Divide y by x. Okay, so what does the decimal do to complicate things? We're not going to know the factors as easy, so we're going to long divide. 15 into 52.5. 15 goes into 52 3 times. That's 45. We subtract and we get a 7. Bring down the 5, and 15 goes into 75 evenly 5 times. 15 times 5 is 75. No remainder. The ratio here is 3.5, but we got to make sure that all the rest give us the same 3.5. So we divide 24.5 by 7. But maybe we shouldn't be doing dividing. Let's do the checking again. Let's see if 7 times 3.5 gives you 24.5. It does. So we get 3.5. Okay, great. All right, 22. 85.8 divided by 22. I don't know. Let's check and see if 22 times 3.5 is 85.8. And it's not. You get 77. It's not 3.5. Stop right there. No way this can be a direct variation. You can check the next one. The next one happens to hold. Yes, 18 times 3.5 is 63. But so what? As soon as 1 point violates it, it does not show a direct variation. All right, great. In the next set of questions, we're looking for the actual equation. Given that we know ahead of time that y varies directly as x, we're asked to find the equation of direct variation. So when y is 45, x should be 15. and we have to find the equation. The equation of direct variation is y equals kx. And our job is to plug in the x and the y and find out what the k is. It's doing the same thing we were doing before. But now it's an equation format. We don't have the table. And so it's our job to divide basically 45 by 15 to get the ratio. 45 by 15 is exactly equal to 3. So the equation is y equals 3x. Number 4, same question, but it looks like it's a little backwards. The y is less than the x, but so what? The process is exactly the same. The equation is y equals kx. Got to find out what k is. Same way we did it with the charts. We divide the y by the x, so we divide 6 by 30. Now we could actually long divide 30 into 6, but I'd rather just cancel. You see, 6 and 30, they share the 6 in common, so we divide through by 6. 6 becomes a 1, 30 becomes a 5. This is 1/5. And so the equation is y equals 1/5 x. All right, great. Last question, number 5. How do you know if a graph represents a direct variation? Let's take our last 2 graphs. We had our last 2 equations. We had y equals 3x and y equals 1/5 x. What's so special about these graphs? They represent direct variation. We just need to write out what's going on in the graph. And it's the fact that it's a line who's going through the origin. If you have a line that's going through the origin, it represents a direct variation. And so that's your answer. Okay, direct variation is about trying to have the equation y equals kx. Y is a constant times x. And finding out what that ratio constant is, k. All right, great. Thank you. Like and subscribe. My daughter tells me I need to say these things. If you have any questions, put them in the comments. Thank you very much.